Today we are starting activity 27, which is all about factoring, and that's the opposite of multiplying. So before we use the box method, we're going to continue using the box method, but we're not going to open the book today. We're going to begin by using algebra tiles to review multiplying binomials, and then we are going to also use the algebra tiles to learn how to factor them, which is our first learning target. So this picture comes from your book. And just a reminder that at the top, if we have this x right here and this x, if we multiply the side times the side, this big square is x squared. Okay. And these long skinny rectangles are labeled as 1. And 1 times x is 1x, 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 or we could just write x, x, x. Those are the same thing. Okay, and then these little smaller squares here are 1 times 1, which is just 1. So all of these are 1s. And then we could count up and we get x squared plus 1, 2, 3, 4, 5, 6 x plus how many singles or ones do we have? We have 9 of them. Okay, so if you're looking at these algebra tiles, which you physically don't have at home, but just like we looked at, this would be x squared This is 1x, so the green side. This is a 1, but if it's a red, that means it's a negative 1x or a negative x. Okay, so the big blue square is x squared. The skinny ones that are double-sided, the green is a positive x, the red is a negative x, and then the little yellow tannish color is a 1. So if we're multiplying, go back to multiplying a little bit because that's going to help us realize what's going on. So if we're multiplying, look, I have x plus 2 because this is a 1 and this is a 1. So we have x plus 2 on the top, and on this side we have x plus 1. Right, this 1 plus 1 makes 2. Okay. So when we go through and multiply this, what do we get? This right here, x times x is x squared. And then remember this is 1x, 1x. X times 1 is 1x. 1 times 1, 1 times 1. If we count these up, what do we get? We get x squared plus 3x plus 2. Okay, so this next example is x plus 2. So I'm going to put 2 green boxes. And then for an x plus 4, I'm going to take these and put 4 of them down here. And then we're going to multiply them or count them up. So move all of these guys and make them fit into a square or a rectangle. And then now, if you're looking, we have 1x squared. How many x's do we have? How many total do we have? And then how many total singles do we have? So it's x squared plus 6x plus 8. Okay, and then this last one here, I'm noticing I have an x minus 2 and an x minus 3. So because I have negative numbers here, that's why we have red ones instead. So we're going to move 2. And then I'm going to put 3 on the bottom. Remember, it doesn't matter where your 2 and 3 go. And then I want to take these single yellowish ones and fill them into the empty spaces. And this is going to form a rectangle. And count them up. So we have 1x squared right here. These are negative x's. How many do we have? And then remember, a negative times a negative makes all of these positive. So we have x squared minus 5x plus 6, positive 6. Because negative 2 times negative 3 gives us a positive 6. So here's what you are going to do. We are given here x squared plus 4x plus 3. And I have the algebra tiles represented on the board. So notice we have 1x squared, we have 4 1x's, and we have 3 little squares. What you need to do right now, and you can do this on a piece of paper since you don't physically have the squares in front of you, is I want you to rearrange these. So take these and you're going to move them. But when you move them, you want it to be a perfect square or a rectangle. Okay, so just think about like when we had the box method, right? It was a square. So you need to move these algebra tiles in a way that forms a square or a rectangle. So if you have something that looks like this, that doesn't work because you have this empty space here. Okay, or maybe you're coming up with something that looks like this. That's not a square or rectangle because you have the empty space. Right? So think, how could we rearrange these algebra tiles to make a square or a rectangle? So if I try to go like this, let's see what happens. So this doesn't work because I have an empty space right here. This does not form a rectangle or a square because this spot or space is not filled in, so it doesn't work. So let's see if I can move. Maybe if I take this one and move it over, oops, move it over here, fill this in right here. Now it's a perfect rectangle. I have no spaces. Okay, so let's write out what the top and what the sides are. Okay, if this is x squared, okay, how do we get x squared? What would this side and this side need to be? This needs to be x, and this needs to be x. And how many green do we have here? 1, 2, 3. So this would be a 3. And how many green do we have here? This would be a 1. Right? Because when I multiply 3 times x. This is 3 x's right now because this is 1x and 1x and 1x, so that makes 3. And then if I multiply over here, x times 1 is 1x. 1 times 3 is 3. This becomes 3 because there's 1, 2, 3 of them. Well, if I add them, I get x squared plus 4x. Remember, our diagonals are our like terms, plus 3. And that's what I started with up top. So here are my factors. Here are my 2 sets of parentheses, x plus 3 and x plus 1. And I know that they're positive because they're green. So what I just boxed in here are my factors. Those are my answers. Remember in activity 5, you were given these 2 binomials and you had to come up with this trinomial as the answer using the box method or foiling. Well, now we're working backwards. So we're given the trinomial and you need to come up with the 2 factors, the 2 binomials. Okay? So let's do this again. So I have x squared, I have 1, 2, 3, 4, 5 x's and 6 singles. So x squared plus 5x plus 6. Go ahead and take the time to rearrange them. Try to come up with a square or a rectangle. So this doesn't work because I haven't used all my pieces. So what if I take and arrange this down here? Now it works because it's a perfect rectangle, right? I have no empty spaces. I have no leftovers. So let's see what our 2 answers are. X, and how many do we have here? Positive 3. X, and how many do we have here? Positive 2. So my 2 answers are x plus 3 and x plus 2. And I want to emphasize that the order doesn't matter here. If you choose to write x plus 2 first and then x plus 3, you're good. If you happen to take this algebra tile and move it down here, we're still okay. This looks slightly different, but this still is the same answer. I just need to change this to a 2 and that to a 3. But again, it's still a rectangle. I have no empty spaces and no leftover pieces. So either way works. All right, try this one. X squared minus 2x plus 1. So make sure that your singles are negative. So turn them over and make them red. So when we do this one, move this guy down here. And it works. We've got a perfect square. So think about the box method when we are multiplying. Okay, if this is x squared, that means this has to be x times x to get us x squared. All right, and this will be a negative 1 and a negative 1. So if I multiply, I get a negative 1x and a negative 1x. Negative times negative is a positive. So if we were to add these, we would get this trinomial that we were given. Okay, but we're focused on the factors here. The two binomials are sets of parentheses, and it's going to be x minus 1 and x minus 1. All right, try this one. X squared plus 6x plus 9. So if we start to rearrange them, this is not going to work, I don't think. I'm going to have one left over. So let's see. What if I take one of these, move it down here? There we go. So what are my two answers on the top and the side? This is x, and how many singles do we have? 1, 2, 3. X, 1, 2, 3. So those are our two factors, x plus 3 and x plus 3. So hopefully you see how this resembles your box method. All right, this is x squared, 3x, 3x, and 9. And if I add that together, I get this trinomial that we started with. But we're looking for the tops and the sides, the two binomials. X plus 3 is our answer here. All right, try another one. Start moving these around. It's kind of just like a guess and check, trial and error. They're red because it has a negative 7x. Oops. So what would our two answers be here? X, they're red, so it's going to be negative, and there's 1, 2, 3, 4 of them. X, 1, 2, 3. So my two factors are x minus 4 and x minus 3. So we're still factoring, we're just not pulling out the GCF anymore. It's a different kind of factoring. All right, try this one. So our two factors, x and a -2, x and a -1. So if we're thinking about the box method to multiply, okay, I could put x and 3 up here, x and 4 on the side. Remember, it doesn't matter if they go on the top or the side. Okay, and when we multiply, x times x is x squared, 3x, 4x, and 12. So my trinomial would be this, okay? And we're going to work backwards to find these. So we're going to put away the algebra tiles, and we're going to not use them because sometimes we have big numbers and we don't have enough tiles. So we could use something called the box method. Okay, so I want us to start thinking about what two numbers, new question, multiply to get 15 and add to get 8. What two numbers multiply to get 15 and add to get 8? So 1 times 15, but when I add them, we get 16, so that doesn't work. 3 times 5 is 15, and we add them, we get 8. So 3 and 5 would be my two numbers here. Okay? So when we're looking at the box method, that's the process that we're going to do. We're going to look at what two numbers multiply to get this C term, that's what we call it, and add to get this B term, this middle term. So multiply to get 4, that's where you want to start, and add to get 5. So if I do 2 times 2, that doesn't work because it equals 4. What about 4 times 1? Does that work? What do we get when we add 4 plus 1? We get 5, so it works. Okay? So what we're going to do is think about the box method or your algebra tiles. What did that blue tile represent that was always in the top left corner? That was the x squared. Okay. So x squared goes in the top left box. My C term, my constant, always goes down here in the bottom right. So that would be 4. Okay. Now, these two that I'm recircling again in black, those are what go on my diagonals. Okay, so I'm going to put a 4 here and a 1 here, but then remember, we have to have x's with them. So go back to this box method. Look, I have an x squared in the top left, I have a constant in the bottom right, and I have an x's on my other two diagonals. Okay, so that looks similar like this. X squared in the top left, constant in the bottom right, and then I have my x's on my two diagonals. All right, now, you think back to your algebra tiles. We want to fill in what goes here, 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 and here. So we want to fill in 4 numbers. Okay, now, you can say what times what will give me x squared, but that's a little bit difficult to think about. So an easier way to think about this is to think about factoring your GCF, just like we did on your test last week. So pulling out a GCF. So look here, I'm going to look at these two, and whatever their GCF is, I'm going to put it here. So they don't share any numbers in common, but what do they share? They share an x. Okay, now let's do the same thing this way. What's the GCF here? And it's going to go there. They don't share any numbers, but they share an x. Now look, x times x gives me this x squared. I could keep going and pull out the GCF from here and put it in this space, or think about the box method. X times what gives us 4x? 4. X times what gives me 1x, or 4 times what gives me 4? That has to be 1. So my two answers here are x plus 4 and x plus 1. Right? I need whatever's in the top and the sides is the binomials, x plus 4 and x plus 1. Okay, let's do one more example, and then tomorrow we'll do the box method a lot more, and we'll add it to a note sheet. Okay, so my x squared, this first term, goes in the top left box. My constant term, my c, goes in the bottom right corner or box. And we're looking for what two numbers multiply to get that c term, the constant that we just wrote down, which is 14, and add to get our middle bx term, so which is a negative 9. Ooh, wait a second. I want to multiply to get a positive number, but add to get a negative. What do we multiply to get positive numbers? A positive times a positive equals a positive when I'm multiplying. But I could never add positives to get a negative 9. So how else can we multiply? A negative times a negative would give us that positive 14 that we need. So both of these numbers here have to be negative. So if I try 1 and 14, if we add them, we get negative 15, so that doesn't work. 2 and negative 7. When I add those, I get negative 9. So that's what's going to work. And now, remember, you have a factored sheet that you can also use to help you. Okay. I'm going to start by looking here and seeing what the GCF is, and I'm going to write it up there. So, x squared and negative 7x. Do they share a number? No, just a variable. They only share an x. Okay, now let's keep going. X times what gives me this x squared here? X times x. Okay. X times what gives me a negative 2x? That has to be a negative 2. X times what gives me this negative 7x? That would be a negative 7. And now let's double check. Negative 7 times negative 2, bam, they multiply to equal 14. So that works. So what are our two answers here? X minus 7, x minus 2, and the order doesn't matter. You could write x minus 2 in your first binomial, your first set of parentheses.